In our next section in 6-2, we're going to look at bisectors of triangles. And the first vocabulary word that we really need to understand, because they're going to talk about it a lot, is called concurrent. And to be concurrent is when three or more lines, rays, or segments intersect at the same point. So, for instance, I have a segment and a segment and a segment. This little guy right here is the point of concurrency. They're going to refer to that. So when you see the point of concurrency, it just means where three or more lines, rays, or segments meet. That's the point that they're talking about. Okay? And the first point of concurrency that we're going to learn about today is called the circumcenter. And the circumcenter of a triangle happens when the three perpendicular bisectors meet. So again, that point of concurrency. So when the three perpendicular bisectors, so remember, to be perpendicular, I have to have this little guy, right? So this is a perpendicular, and I know it's the bisector because these guys are the same, right? So I'm just looking at this segment right here, and I can see this is the perpendicular bisector because this is perpendicular, and these two guys are the same. So the same thing over here. So from here to here, I can see this is the perpendicular bisector. These two are the same. And then I can see this guy right here is the perpendicular bisector to this side. And then these guys are also the same. So this little point where they meet is called the circumcenter. It's the place where they're concurrent in a triangle. It has this point of concurrency, just has a special name. It's called the circumcenter. Excuse me. And there's a theorem that goes with that circumcenter, and it just states that the circumcenter of a triangle, so that dot that we were just talking about, this guy right here, is equidistant from the vertices of the triangle. So it's saying that this point right here, this circumcenter, is going to be the same distance from that guy, which is to that guy, which is to that guy. That this distance right here is going to be the same as all of these. That's what that circumcenter theorem tells us, is that if we have a circumcenter, we can look from each of the vertices and know that from the circumcenter, all of these are going to be the same. And of course, then that's when the algebra comes in. Like if they tell me this is 8, I know this is 8, and I know this is 8. But of course, sometimes they give us some letters, right? They'll say like 2n plus 5 or something, and I have to do some solving. The last theorem today is called the in-center. So the in-center of a triangle is another point of concurrency. It's a different kind. And the in-center this time is equidistant from the sides of a triangle. So when they're talking about the in-center, this time I'm going to see that it's the same from all the sides. So I'm sure my picture isn't going to be super awesome. But so they're saying that from this side to this side to this side would all be the same length to find my in-center. And it's not always going to look exactly like this. I should maybe draw like a different triangle. But so it's the same distance from here to here to here. That's called the in-center. So what I kind of noted for both of these, to make sure that you're paying attention to which one they're talking about. In the circumcenter, we're equidistant from the vertices, and the in-center is equidistant from the sides. So those are the two things that people get kind of confused about between the circumcenter and the in-center. So the circumcenter, you just got to pay attention. It's those vertices. It's the same distance from the vertices. And the in-center is the same distance from the sides.